Okay, so part two, integers. So integers are whole numbers, that is, numbers that do not have a fractional component. Um, and we have this table here of operators. So these are the operators that will operate on integers. Mostly you're only going to be concerned with, the top four of these, add, subtract, multiply, divide. There are a whole bunch of other ones here. You also use these a lot, the equality operators, so equal, not equal, less than, greater than, less than or equal to, greater than or equal to. These in the middle here, these are bitwise operators. So an integer in memory is a is a number of bits, and these operators will operate on those bits. And unless you're doing, occasionally you might have a need for doing bitwise operations, but mostly this is going to be pretty rare that you have to think about this. We also have exponentiation, and then this modulus operator we'll talk about briefly. Also, so if you didn't check out these cheat sheets, there's a number of external resources I have linked here that, let's just look at this one here. This is just a simple one-pager quick reference that has operators and various functions on some of the other data types we'll be talking about that can kind of be just a quick glance look to if you forget um, how to spell out an operator or what function to call. Okay, going back to integers, let's look at the code in VS Code. Okay, let's open up a terminal here. All right. So, assignment. So let's assign the integer 3 to my int. So equality works this way. And when we're assigning an integer to a variable like this, in memory, what is happening, right, is we are reserving a chunk of memory and putting the bit representation of that integer into that chunk of memory. And in most languages, integers will default to the word size of the processor, which these days is pretty much ubiquitous. It's 64 bits. And let's just run interactive Python here. Now in binary, the largest number you can represent in base 10 with a given number of bits, let's say 64, is 2 to the 64th power minus 1. So if we have a 64-bit integer, we can't actually represent in memory a number greater than this. But you'll notice down here, holy crap, let's see if this actually works in Python. Well, actually, let's just enter a breakpoint here. We don't need the import because I've already done it for you. Let's exit out that. Okay, module 2. So when we do a breakpoint, it'll stop it at the next line. So this has executed, which means this evaluated correctly. So let's look at this integer. That is significantly greater than 2 to the 64 minus 1. And that is because Python will allow you to represent arbitrarily large integers. When it overflows that 64-bit boundary, it just allocates more memory. And so this is more than a word size of memory in RAM. So you don't really have to think about overflows in Python. That is a feature of a lot of other languages with integer arithmetic. Not a problem for Python. So the operators. So let's step through this. When you're in the Python interactive Python debugger, you have a few commands available to you. You can see them if you just type help. It'll give you a list of things that you can do. One we're going to do right now is next. We're going to step through next, and just n is a alias for next. So if I type next, oops, we're going to see that it progressed through the code statement by statement. So if I just say n, all this is working. And what we were doing here, we were just stepping through some, so we added 1 to my int, and okay, so what's important to know here, when I added 1 to my int, it did not change the value of my int. This is an expression. And as we talked about in the opening to module 2, expressions always evaluate to a value. But unless you assign that value to something, it's sort of ephemeral. Like it exists for the length of this statement, and then it no longer exists. So when we add 1 to my int here, we can say, oh, this expression equals 4, but we didn't store the value of this expression anywhere. So when we get down here to line 67, my int is still 3, and so when we subtract 1 from it, it is now 2. We also have these assignment combination operators. So if you see a plus equal, minus equal, times equal, divide equal, this is taking the value of my int plus 1 and assigning it back to my int. And so we can follow through these assert statements here. I promised we talk about the modulo operator. So what modulo is, well, you do it with the percent. So let's see what my int is right now. My int is 4. So a modulo means remainder. So if I said modulo 2, since 2 divides evenly into 4, the remainder is going to be 0. So that's 0. If I did my int modulo 3, 3 divides into 4 once, should be remainder 1. So, and a little hint, you will be needing the modulo operator in one of the first few gateway assignments. So don't forget about that.